Thank you everyone for coming today. Well, my name is Darin Fisher, and today I'm going to talk to you about the WebKit API that we've been building for Chromium. So first question, why bother doing this at all? Mainly it all boils down to solving some of our maintenance problems. This is all pretty straightforward. WebKit's a very fast evolving code base. If Chromium were to just use the internals of WebKit directly, that would mean that Chromium's repository would constantly be broken as WebKit changed. And we wanted to avoid forking WebKit. We didn't want to just create a vendor branch and live on a vendor branch forever, because we really want to be in a position where we were adding a lot of cool new features to WebKit, constantly changing it. So it was important for us to be able to live on the tip of the tree of WebKit and work with the rest of the WebKit community to add new features. And paramount to this is that Chromium needs a way to be able to stay on the tip of tree. So a stable API in the WebKit repository is very important to us. Wait, so WebKit doesn't already have an API? Well, of course it does. Actually, all the other consumers of WebKit are in the exact same position as us. They've all had the same exact need, and they've built their own WebKit APIs that live in the WebKit repository as well. For example, Apple built an Objective-C and a COM API for Safari and other WebKit-based products. And other folks have done the same. There's a Qt variant, there's a GTK variant, WX Widgets variant, and so on. All of these, though, have the property that they're a bit coupled to the operating system. And so given Chromium's constraints that arise because of the multiprocess architecture, and in particular our sandbox, none of these APIs were sufficient. They all basically were very coupled to the operating system. And we needed something that was just much thinner, much lighter, and really just about getting access to WebKit's rendering engine capabilities. So we want to be able to feed data to WebKit and get pixels out. That's basically what we were looking for. Going back. Whereas a lot of these other APIs are all about, asking WebKit to give me a widget, a Cocoa widget that can be included in my program, or a COM control that can be included in my program, or a GTK widget, and so on, where underneath that widget is really all of WebKit talking directly to the operating system for both to access the network systems as well as the file system, as well as a variety of other things. And our sandbox technology is all about denying WebKit access to the file system, denying it or limiting its access to the network, limiting its ability to interact with other things, in particular like the desktop system. So we don't want WebKit directly talking to HWinds and so on. We want to be able to abstract that away. We want to just, like I said, feed it data and get pixels back. So a little aside about the WebKit source structure. On the right, you see a little diagram there. That's what a typical stack looks like. You've got the embedder at the top, say Safari, talking to its own WebKit API, which is implementing various client interface. These are callbacks from WebCore, things like notifications about various state changes. WebCore might need to ask the embedder, hey, what's your decision about this policy? Or please choose whether or not I should proceed with this resource load. And so these interfaces are all well designed for this stack. Below this, you see a platform layer that WebCore defines, which is really like a porting layer, which is implemented for various ports in terms of operating system calls. So this is sort of the lay of the land. A little history for us. Chromium's original solution to this whole problem was to set up something in the Chromium repository called SRC WebKit Glue. This layer of the Chromium repository used WebCore directly. It was sort of served the same purpose that a WebKit API would serve, except it lived in our repository. It was coded using Google C++ style instead of WebKit style. If you're familiar with those styles, they're very different. It also, over time, grew to use a lot from the Chromium repository, in particular base and net and other submodules. One big deal for us, though, is as we were taking WebKit merges, frequently we'd find that we need to scramble to make changes to the WebKit Glue layer to account for the fact that WebCore is changing a lot. And so this added to a lot of messiness at this layer. And a lot of times that messiness compounded problems for people when they were trying to understand, how do I add a new feature? And looking in WebKit Glue, it seemed like a big confusing jumble. And trying to navigate that and produce good improvements to that really just increased and added to the entropy, and really led to a lot of cleanup work in order to disentangle all of that and refactor it extract from it some meaningful WebKit API that we could push upstream. So yeah, it just needed to be cleaned up. So what's the status? So today, it turns out, after about 9 months of hacking, we are mostly upstreamed. In the WebKit repository, there is a Chromium directory under the WebKit subdirectory with a public directory containing our API interface and source directory containing the implementation. Pretty straightforward stuff. For those familiar with WebKit APIs, this means that stuff like WebView, WebFrame, and all that entails is expressed here. We still have some more remaining WebCore dependencies. We have more work to do to upstream some things, but these are not a whole, this is just busy work, I would say. We've got some things here that are many of these are actually underway. DOM serializer is practically done. An interesting tidbit, though, we have accumulated a bunch of unit tests because as we were developing Chromium, we really like to build unit tests, and so we built unit tests for WebCore specific things even, and WebKit Glue specific things, which are now WebKit API specific things. But the WebKit project has no unit testing framework. They only have a layout test framework. So there's not really good home for these unit tests yet. So it's an open question what we're going to do with them. But getting back to the original problem, having code in the Chromium code base that directly uses WebCore adds to maintenance hurdles. So we really want to eliminate these WebCore dependencies from our code base. So it probably means extracting some of these tests and pushing them into the WebKit repository in some form. More status. So though we're not done upstreaming, the interesting thing is that we are actually, what we have upstreamed is fairly complete. You can build a DLL from it. This is a big accomplishment for us because previously the code we had in the WebKit repository was all sort of like a tree without its roots being fully there. We had all these back dependencies to the Chromium repository or things that were just not defined yet. So now one can look in the WebKit repository, look at the Chromium port, and see how various WebCore interfaces are implemented. See what the complete picture is for the Chromium port. And that's a big step forward for us. The dependencies that we do have, or some of the major ones are listed here. Obviously, we depend on WebCore, and WTF is just a low layer, a utility layer in Java in WebKit. Instead of using JSC, we use V8, but I put the asterisk here because actually the WebKit API doesn't really necessitate the use of V8. It just facilitates it. And it's possible to take the Chromium WebKit API and use either JavaScript engine. Skia is the graphics engine that we use on our Windows and Linux ports, but on our Mac port, we actually use CG. If you were to take the WebKit and build the Chromium port for Mac, you wouldn't be using Skia at all, and you wouldn't need this dependency. So the WebKit API is sufficiently abstracted these differences in the underlying graphics engine. Google URL is the URL parser that we use in Chromium, and it's a dependency. But actually, this one is also optional, but we haven't really done the if-defs to make it optional. And then, of course, there's the usual dependencies that are shared by pretty much all the WebKit ports. So where we are today is you can take update WebKit, build WebKit scripts, pass the -- Chromium command line parameter, and you can actually go and build the Chromium port. We're very close to having this all working properly on build.webkit.org. I put quotes around work because the product of this is not yet something you can use in Chromium. One day it would be nice if you could build directly out of Chromium, out of WebKit's repository, and get something that you could then exercise in Chromium, much the way that Safari engineers do with WebKit. They build the WebKit framework and they run it with production Safari. We should be able to do the same with Chromium. So now I'll talk a little bit about how the WebKit API is designed. Some of the sort of the high-level objectives. We were looking to build something that has good source compatibility, but not necessarily binary compatibility. What do I mean by that? If we have a virtual table, it's okay to add new methods in the middle. It's just not okay to delete a method until you're sure that all consumers no longer need it. So we have to have a deprecation process. For us today, we haven't really well defined that process, but it probably will involve something like, deprecated APIs stick around for a quarter or two, or a couple iterations of products that are depending on the APIs. So we're trying very hard to not remove things to make it really easy to add things, but not necessarily make it so easy to remove things, because we want to make sure that it's easy for somebody to take a older version of Chromium and run it with a newer version of WebKit. And I'll talk more about that later. Also, one of the main goals here was to make this layer as lightweight as possible. And I'll give some examples of that shortly. And of course, it should be using the WebKit coding style. This is very important because we want to make sure that folks working in the WebKit community are very comfortable making changes here. So as I mentioned before, the glue layer, which we were taking and translating to WebKit API, had to be all converted. So there's a lot of busy work there. And we chose to avoid STL containers because that's actually a rule in the WebKit code base. They use STL algorithms and so on, but avoid the containers. It turns out that talking to the Android team, they also really prefer to avoid STL containers. There's various reasons for that, which we can talk about later, but I think it has a lot to do with memory allocation issues and having a good STL implementation everywhere and so on and so forth. But this turns out to not be a hard constraint for us because WebKit has WTF, which largely provides equivalence. But just on that note, we avoid exposing WTF through the API. So that means that consumers, all they see is WebKit API. They don't see WTF types. So it did mean that there's some awkwardness when we want to, say, expose a vector of things outside to the outside world. Anyways, looking at the layers of WebKit. So I showed before a diagram that had WebCore and client interfaces above it and platform layer below. And given Chromium's constraints that I talked about before, multiprocess architecture and so on, it was necessary for us to give the consumer, the embedder, the ability to implement many of the things that are traditionally platform features in WebKit. So if you were in WebCore today, you would see this class called Chromium Bridge with a bunch of static functions on it. It looks a bit ugly because it's just a class with a whole bunch of static functions that seem to have nothing to do with each other. What they are is just a collection of all the things that need to be handled by the embedder. And so what we've done for simplicity so far is to just give them a common namespace and then implement them in terms of WebKit client, which is a virtual table, calling out to the embedder to allow them to define how these things are done. I'll talk more about specifics of what I'm talking about here, but it's things like loading, a request to load a network resource. What is the time of day, and various other things that the embedder might want to control. But at the very top, all the client interfaces that WebCore calls out to, well, those are translated pretty much directly to other client interfaces defined at the WebKit API layer. So for example, Chrome client calls or editor client calls or things that are typically associated, clients that are associated with the WebCore page are expressed at the WebKit API layer in terms of WebView client calls. Similarly, if you're familiar with the frame loader client, those get translated to a WebFrame client. Anyhow, those are all callbacks to the embedder. The embedder can then use interfaces like WebView to talk to the WebCore page, or WebFrame to talk to a WebCore frame. These names, WebView, WebFrame, they come from existing WebKit APIs. So I spoke before about how we tried to make this a very lightweight interface. So this is just a small example. We knew we needed to pass strings back and forth through this interface. WebCore strings is WebCore string is the underlying type that WebCore uses to manage strings, but it's implemented in terms of the string impl class, which is really just a reference counted little doohickey. And so we realized that if we present an interface such as you see in webstring.h there, that basically we could give consumers something that was very lightweight, that was it was basically as cheap as a WebCore string. So whenever you copy a web string, it will basically addref the string impl, and just as if you copied a WebCore string. And if you convert a web string to a WebCore string, it's again just an addref on a string impl. So we use this pattern routinely in the WebKit API to expose any type of WebCore type that is reference counted. Works out very nicely. Gives us API installation and avoids the leakage of WebCore interfaces and WebCore types to the consumer, but gives us very little cost. Yeah, so API usage, a little bit about WebKit client. So in order to get going using the WebKit API, you have to implement WebKit client. And then it's just a matter of using the WebView and various other interfaces to do what you need. Here's just a small sampling of some of the things you'd find here. WebCore needs to know information about the MIME registry when it's loading resources. So the embedder has to provide that information. So there's an interface for that. As you can see here, when WebCore wants to load resources, he needs to ask the embedder, hey, load some resources for me. So there's an ability to create a web URL loader. I mentioned before about time. This is an interesting one, so that's why I mentioned it here. We let WebCore ask us what the current time is. And this is important for us because it allows us to have one clock for the entire product. WebKit does have its own implementation of current time, of get time of day, and so on. But if it is subtly different than the one Chromium uses, then we can have very subtle bugs that are very annoying. So instead, we just let WebKit ask the embedder, what is the current time, and then we can use a unified clock. There's a whole bunch of other things here. Some of them are not as simple or clean as what I've shown here, and there's probably room for improvement here. Anyhow, but just to give you a feel, this is what you might need to do, a basic embedder might need to do to get started going with this. They will need to initialize WebKit by providing a WebKit client implementation, and then they would have to go and create a web view, which corresponds to a page. And finally, initialize the main frame of that guy, providing a web frame client. This web frame client will be notified of events for any frame that's constructed underneath this web view. So if you have a frame tree, like iframes and so on, the events associated with them will be sent to the web frame client. Anything that's more at the page level that's not frame specific will be sent to the view client. And then that's it. So that's just a small sample. There's much more. So what other things are we worried about going forward? Well, we have a set of to-dos still. I mentioned that we're not done upstreaming. That's the biggest thing. We need to get rid of all the WebCore usage in the Chromium tree. We want to then proceed to implement dump render tree on top of the WebKit API. Dump render tree is the tool that all the other WebKit ports use to exercise WebKit's layout tests. So it's very important for Chromium that we're using the same exact tool. Many of you know how frustrating it is when a new feature is added to dump render tree, and we have to go then re-implement exactly that feature in test shell in order to be able to run the layout tests. It's very frustrating. Instead, it would be nice if we were all using the same code base for exercising the layout tests. Once we've done this, we can move all of the expected layout test results into the WebKit's repository, and the net result of this is that if you're working on the Chromium port of WebKit, you can do so all out of the WebKit tree. You have all the tests there and the ability to run those tests just as any other developer of any other WebKit port would have. Finally, what this means for Chromium is that we won't have to be taking daily updates every day into the Chromium trunk of WebKit in order to stay afloat. Instead, we'll be able to wait for WebKit. We can take WebKit updates less frequently. This is really great, I think, during, say, stabilization periods of Chrome. We should be able to go a month even before we take a WebKit update. And yet, we won't fall behind because the canary bots, the canary configuration, the one where it's pulling both Chromium typetry and WebKit typetry, will still compile, still run, and we'll still be able to maintain and update all the layout tests and so on and so forth. And keep that one ready to go so that when we are ready for the Chrome trunk to take a new WebKit, it's not a scary deal because it would have been vetted by the canary bots. And so finally, this allows us to better participate. We basically would be operating much like Apple does when they work on WebKit or other folks do when they work on WebKit. And I think that's really great for us. So any questions?
And you have a question, we have a mic. Yeah, no? Any questions?
So if we're stabilizing our trunk once this is all upstreamed, and we've got the canary bot running layout tests, when WebKit changes their behavior such that layout test results change, how do we actually do that on our side? Are we planning to annotate our layout tests so that we can have two sets of results, one for the canary and then one for the current snapshot that we're using?
So it turns out that we don't need to worry about that. It turns out that if our WebKit test results, our expected results, and the test expectations file all live in the WebKit repository, then it's not a problem because the canary configuration will be surfing the tip of tree, which will have to have the updates. But the Chrome tip of tree will normally be surfing some stable older version of WebKit. But again,
Right.
It'll have that historical results.
Are
you
our
know.
layout tests already in the WebKit repository, or are they still in our repository?
Our layout test expectations,
Yes.
those are all in the
And
Chromium
results.
repository. Yeah, the expected results are all in the Chromium repository. So that makes it a problem. It's much like having a dependency on WebCore.
So that's another future task.
Yeah, it's a big one, but we've already got the wheels spinning on that one.
Is this API going to be useful to anybody other than Chromium?
Great question. Actually, this was something I meant to talk about. I believe that this API is quite useful to other ports or other consumers of WebKit. Because of the fact that we had the sandbox constraint, because we had the multi-process constraint, because what we ended up building was something simple that's just, the bare minimum. You provide data to WebKit, it gives you pixels. It seems quite applicable to other use cases. We don't have dependencies directly on the operating system APIs for various widget stuff. We do use GDI on Windows in order to render fonts, but our Linux port is using, it doesn't have those kinds of dependencies. So it's interesting, and as I said before, we're using core graphics on the Mac, but Skia on other platforms. So if somebody has yet another graphics layer that they want to use, they could use our WebKit API to support it.
So in particular, to follow that, are we talking with the Android team about?
The Android team is very interested in this as well. I mean,
Okay.
they have similar needs, similar requirements in their world. They bridge out to a Java-based embedder, and so this model seems similar, and it seems of value to converge.
So you mentioned that building the Chromium, the WebKit API upstream out of the WebKit repo has dependencies on V8 and Skia. How does that work, given that those are only checked out in a Chrome G client?
Oh, so the Skia and V8 dependencies are really similar to libxml dependencies and ICU dependencies.
Okay.
If you think about it, to build WebKit today, you need a set of external libraries, third-party libraries. So V8 has a stable API. Skia has a mostly stable API. And so grabbing these and treating them as just third-party dependencies works pretty naturally.
Okay, I guess I'm just not that familiar with
Mhm.
how WebKit pulls in those third-party dependencies.
So there is one little, there's a footnote there, which is that today we do have a dependency on source/Skia/ext, which is a set of Skia utilities that we put together that are not yet part of the Skia proper, and they're not in WebCore, so they're this yet another little module that we depend on. But if you take a look at how update WebKit -Chromium is built, it actually under the hood does something similar to gclient. It goes out and fetches the set of dependencies. Or does it even use gclient? Yes, Yar says yes, it uses gclient. So we have a deps file or something equivalent that we maintain in the WebKit repository that indicates what the Chromium port needs. And some of those do point back to the Chromium repository for isolated things.
Okay. One more question. So a few of us have been working upstream in the WebKit repository and been relying on frequent pull downs from WebKit to Chromium in order to be able to make sure that everything is working well in Chrome. Having a month delay between rolls of WebKit would really impact that ability to.
Right.
I think it would actually impact our ability to contribute to WebKit at all.
Well, so we don't actually have a month delay. What I was trying to say is that we partition our world. They have the canary configuration. You can contribute to go full steam on WebKit. But if for Chrome, we decide that all of Chrome team should be focused on the next milestone, stabilize for the next milestone, then naturally we don't want to take disruptive changes, right? So naturally we're not going to be wanting to take any large changes to Chromium during that period of time. So this is about giving us opening up and giving us that opportunity to say, for this month we're going to have a stabilization of Chrome. But by the way, we don't want to fall behind on WebKit. So we can continue development on WebKit. Maybe we can get fancy with ifdefs in the Chromium repository, but maybe we don't need to, because after all, most Chromium developers during such a period of time would be focused on stabilizing Chrome. Does that make sense? So we have two worlds that we can live in. One where we are taking the tiptree of WebKit. New features are being added. New WebKit APIs are being added in anticipation of them being used, perhaps. But we don't yet take the changes to Chromium because we're stabilizing.
And there's no reason why a developer couldn't
You need a mic, I think.
And there's no reason why a developer couldn't be using the upstream version, on their local client. It's just that wouldn't be the main checkout that everybody was using.
There's a problem with that, as I've just run into, which is that if the entire Chrome team isn't sort of doing these WebKit roles, then incompatible changes made upstream aren't being fixed in the Chrome tree, like this history custom binding that was just added to the IDL file. And so then the developer that's trying to do the work upstream is saddled with basically doing WebKit roles in order to
Well,
be able to.
let's take the history change in particular. I think that one can be, the fixes for that are entirely within this WebKit repository, unless it's about actually implementing the feature that was added.
Yeah, it's about implementing custom bindings in V8 for a couple
So custom
of,
bindings in V8, they all live in the WebKit repository.
right, but somehow these weren't made by the WebKit team when they added these two new functions, and so the Chrome team is saddled with having to go and implement a whole bunch of stuff and check it in upstream. And this should have been caught earlier, as was pointed out on the Chrome team, but my basic point is that if as a team we aren't keeping up with the current WebKit, then anybody on the Chrome team that's trying to do upstream WebKit development is going to have a real problem.
No, but yes, this is true. And in fact, the goal here is that there's a sub-team of folks who are focused on WebKit for Chromium's benefit, who they themselves are living with Canary configuration. They themselves are maintaining this. Just as today we have a set of WebKit mergers, gardeners, who graciously spend their day trying to keep the WebKit Chromium port afloat. That will continue. That doesn't change. But they'll be able to do all of their work in the WebKit repository. The goal is to eliminate the two-sided merges, the two-sided patch landings,
Okay.
because the WebKit API gives us insulation.
Sounds good. Thanks.
What's the rationale for not doing a binary compatible API or a C API?
We had no need to do a binary compatible API, and so we didn't want to impose that constraint without it being necessary. Like I made the point, in previous projects I've worked on where we had to try to have a stable API, it meant very carefully adding a new methods to the end of a vtable, or being very careful about not adding a default argument to a function, but instead creating a new function, or having some system to be able to query additional interfaces off of a class. And pretty soon it gets pretty complicated. I'm not a big fan of COM and things like that, and we don't need it, frankly. We just needed source compatibility. So let's keep it simple.
You did say that it would be possible to take a new WebKit build and run it dynamically inside of Chromium binary, but that seems to imply binary compatibility.
Yes, it does.
So you're saying that will just break
I
from time to
actually-
time if things change in the API?
What I meant was that you should be able to, I did say that, but I'm not sure that is an interesting goal long term, contrary to what I just said. But I think that short term, there's still the goal that you should be able to compile a WebKit using WebKit's build tools and build system, produce a DLL, then compile Chromium against that set of headers, right? So you still are fine, provided you're compiling Chromium against the same set of headers. You don't need binary compatibility. So what I'm saying is that we should be able to live in this world where we don't have binary compatibility across versions, but we do have source compatibility, but we're still able to have a DLL of WebKit and benefit from that. Does that make sense? There's sort of this wonderful interim where we get the DLL and we don't have a giant massive Chrome.dll, but we have a WebKit DLL, and then Chrome DLL has the non-WebKit parts.
Right, so as long as the WebKit headers don't change,
Yes.
you can interchange the DLL
So-
without having to rebuild.
That's right. So you would rebuild if you were updating your WebKit tree. So but again, if you're using a Canary configuration, then you just do gclient sync. You get new versions of each. Point is that if you were to go into the WebKit directory and type build WebKit, it should work. And if you were to type update WebKit, that should work. And then you'd have to go rebuild Chromium. But the Chromium build system would know what to do because it knows to look in the WebKit directory for headers. Not quite exactly the same thing that the Safari engineers have because they actually have binary compatibility. Anyways, thank you.